Okay, so last time we did sections 2.2, we finished it, and we did 2.3, all in the same day. All right? So what does that mean for homework tonight? Both of those things are due tonight. 2.2b and 2.3 are due tonight. So today we will do section 3.1, which is a fairly short section, but it will give us time to do some sort of outside learning, teach you how to use your calculator to do simple summary statistics. Okay? So any questions before I get started on that? Everybody good with section 2.3? All right. So section 3.1 is titled Measures of Center. Okay? And so I put the word center in quotes. The book doesn't put them in quotes, but I like to put it in quotes because that word might mean something different to you. So I want you to understand that center, you have to say, what do you mean by that? Well, I started to show it, but well, I'm going to. Sorry. Let's turn this on. And I'm going to go up to this is histogram of heights for females. Right? Describe the shape of this distribution. Bell-shaped and? Normal. And symmetric, which means normal. Right? So this is a normal distribution. What's the center of this distribution? I say, what's the center? And people start squinting and looking, trying to read the numbers. Yeah, if you look at this, the center is 65, right? Approximately 65. So when I have a nice symmetric bell-shaped distribution, what I mean by center is pretty straightforward. Oh, it's the middle, right? Now let's look at the age distribution. What's the center of that distribution? You see that we have a huge hump here, and then this really long tail. So we have what's this kind of a distribution called, by the way? Skewed to the right. Skewed to the right. Right? So we have a right skewed distribution. What's the center of this distribution? 28. Okay, I heard somebody say 28. What do I mean by center? That's the point. Well, I got values of 18. I got a value of 87 halfway between those two numbers. Wouldn't that be the center? That's one way to define center, but it's not how we mean it in this class. Center means like typical. What's the typical observation? The typical age. Right? So center, think of as meaning typical or average. And the word average is dangerous for me to use because that word gets used in a precise way sometimes to mean the mean. But in everyday language, when people talk, you know, they say, "Oh man, he's just average," right? He's not acceptable. He's just average. So it means typical. So when we want to compute the average of something, we won't call it average in this class. We'll call it mean. We want to compute the mean. Understand? So when we say measures of center, we mean typical or average age. So say it again. What do you think the typical age is in this data set? 18, 19, somewhere in there? Right? And what do you use to base that on?
Yeah, percentage.
Okay? You're looking at the percentages. Those are where the tall bars are. So most of this sample, 365 observations, most of them fall right in there. So that's what's typical of this data. These are called outliers. Good, right? So when you talk about measures of center, you don't want to include outliers as part of that. Okay? So, like I said, let's go back to that height one. If you have a symmetric bell-shaped distribution, then there are no outliers. So measure of center is pretty easy to define. Well, we're going to have 3 different measures of center that we'll talk about in this class. There are others, but they're not as typically used. So the first one is the mean, then the second one is the median, and the third one is the mode. You probably learned these things when you were in 3rd grade, right? Mean, median, and mode. So you're thinking, man, this is easy stuff. Right? Yeah, it is fairly easy today. But we're going to start with mean. All right? Now I want to show you, well, before I do that, I want to give you some notation. So if I compute the sample mean, well, let me ask you. When in 3rd grade, when you learn to compute the average or the mean, how do you do that? How do you compute the mean of a set of observations?
Add observations and divide by the of observations.
Okay, exactly. You add them all up and you divide by how many you added, right? So there's nothing difficult about that, right? But we need to make it look impressive, so we need to put some symbols in there and make it look like it's hard, right? So in math, does anybody know how you denote sum them up? Sigma, very good. So sigma, the Greek letter sigma, and there are actually 2, every Greek letter, just like our alphabet, has an uppercase and a lowercase. This is uppercase sigma. We will also in this class deal with a lowercase sigma, which looks something like that. As best I can draw it, right? This will stand for standard deviation of the population, right? But don't worry about that. That's Friday. We'll get to this Friday. So this is lowercase sigma. Uppercase sigma looks like that. It's the one you see on the sides of the frat houses, right? But in mathematics, it means summation, right? So to be real precise with it, we won't be. So I'm gonna write this. You don't have to, and then I'm gonna erase it. But we'll say this. So this is just called an index. For index equal 1 up to n. Right, now what is n? Number of observations in the sample. So it's sample size. Right? So then I'm going to sum up all of the x values. And I put a little subscript of I to match this, meaning first observation, second observation, third observation, up to the nth observation. I'm going to sum them all up. Now, this author in most beginning statistics books will suppress this I equal 1 and this n, and they'll just use that sum where it's pretty well understood I'm summing up all of the x's. Okay? But the little subscript of I they maintain on there just to say I have n of these ages or these heights or whatever, and I'm going to sum all n of them up. And then I'm going to divide by n. So that looks real impressive, but it's what you learned in 3rd grade. Add them all up, divide by how many you added. That's all that means. Now I'm going to give this a symbol, the letter x, because that's the variable I'm dealing with a bar over it. So we read that as X bar. Right? Now, there's nothing magic about the X. It's just a placeholder. So if my variable was Y, I could have Y bar. If my variable was Z, I'd have Z bar. If my variable was the word height, and I just used that as my variable name, then I have height bar. Right? So a lot of times we'll use letters like the first letter of the word. If I want pulse, I might use a P. If I want age, I might use an A. So A bar would be the average age. Right? And that is the sample mean. Right? So then the population mean, we use a Greek letter mu. So that's the Greek letter mu. The formula is the same, except if little n is the sample size, if I'm talking about the whole population, I don't have a sample. Right? I have the whole population, so we use a capital N. So that's population size. Okay? Now, a little bit of review. If you're talking about a characteristic like the mean of the whole population, what is that called? What did you say? You would have to take a census to get it, but it's a characteristic of the whole population, like the mean. It's called a parameter. Remember that? Have I ever mentioned that the final is comprehensive? Okay, just check it. What is X bar? If it's not a parameter, it's a characteristic of a sample. What's that called? A statistic. Good. I heard people flipping back through their notes. Good. It's a statistic. So X bar is a statistic and mu is a parameter. Now, what did we say back then about parameters? They are usually unknown or unobservable, because most of the time you can't actually take a census of the whole population to compute what you want. If it's a small population, possibly, but most of the time you can't do it. So what we do is we use sample statistics to estimate population parameters. I don't know what mu is, but my sample, I got 65.1 inches, so that's probably pretty close to the population mean. Understand? Okay, so that's just notation. Okay, now I want to, let's come over here and I know, I'll move this. Let me write down some data values. Let's go 4, 8, 1, 3, 6. Yeah, that's good enough. Right? Compute the mean of that. You might be able to do it in your head, but I wasn't careful on how I set up the numbers. But 4.4? Is that to one decimal place, or are there more decimal places?
Just 4.4.
Okay, good. 4.4. Usually I try to plan ahead and use numbers that you can actually do in your head. But 12, 13, 16, 22 divided by 4 isn't a nice whole number, but 4.4. Everybody understand how to do that? Okay. So that's the mean. It's a measure of center, right? Measure of the typical observation. Now, back to this. What's the median? First in words, what do we mean by that?
Number.
The middle number. Good. So the median is the middle number. So what's the median of this data set?
1. You got to organize it first.
See, I suckered them in. sucker. I knew I could get somebody. 1 is the middle number when it's written like this, but you gotta organize them first. And organize, you mean put them in order, right? So the ordered list is 1, 3, 4, 6, 8. So it's the middle number of ordered data. You've got to put them in order first. And that's a real common mistake, and you know it in your head that, yeah, you got to do that, but it's easy to forget in the heat of the battle on a test. All right? So the middle number. So what's the median?
One that occurs most often.
No, I'm still on median. Middle number is 4 of the ordered list, right? So there's my median. All right? Now, this book is like just about every other statistics textbook. They don't give us any symbol for median. They have all these fancy symbols for means, but they don't give us a symbol for that. That always bothered me. Even back in grad school, it's like, why don't they give us a symbol for median? I don't know. But so I choose to say capital M is the median, but you won't see that in the book. Our calculator will call it MED, the med, short for median. Right? Now that's easy enough when you have an odd number of observations, but let's add another observation. Let's add a 12 to this. Now what's the median? 5. Good. And those of you that knew that, what are you doing? You're averaging the middle 2 numbers. If there's an even number of observations, then there won't be a single middle number. There's 2 middle numbers, so you just average them. So the average of these 2 is 5. Okay? Now that's easy when you have a data set with 5 or 6 things in it. What if you have a data set with 365 things in it, like our pulses? How would you get the median pulse if you got 365 observations? Well, really, the correct answer is I'd let the computer do it. Right? But let's say we have it in Excel, or even the Google Doc will do this. Right?
There are numbers, so you can figure out which one your middle number is and go right to it.
Exactly. So if it's in Excel, the easiest thing you can do is click into the column that has the pulses. Just click anywhere in that column, and then go up and find the sort button and say sort smallest to largest. And it'll rearrange, and they'll all be in order. And then you just go down to which observation.
Middle one.
The middle one. Okay, what's the middle of 365?
Between 182 and 183.
Between 182 and so if you average, or if you take half of 365, you get 182.5. So it'll be, see, 365 is an odd number. And I have an odd number. Before I added this 12, I had 5 things. The middle number was the third one. If I take 5 and divide by 2, I get 2.5. The next whole number above 2.5 is 3. Third one is my median. So, which is my median going to be? 183. You go to the next whole number above 182.5. Got it? So that's really easy to do. Even if you have a lot of data, you just let the computer sort it for you, and then go pick off the middle one. Right? Easy enough. Right? Okay, now let's come back to this data here. Erase my little chicken scratch. So the median here we decided was 5. Right? Notice, oh, I thought that was mean. We did not recompute the mean of this data set, right? So what is X bar? Add this 12 to the 22 that you had before. You get 34. Divide by 6.
5.6.
What is it?
5.6 repeating.
5.6 repeating. Okay? Now what do you notice about the median and the mean? They're roughly the same. Pretty close, right? All right. Now, I'm going to teach you how to use your calculator a little bit. Now, while you're doing this, I'm going to pull up here the e-book And I'm going to show you that in your book are these instructions. So if you don't get them all scribbled down, don't panic. So this is page I don't know. Are the page numbers at the top or the bottom? Apparently the bottom. I guessed wrong. Page 131, down at the bottom. There's other pages that have really this same set, but all through your textbook are calculator method, right? And it's the TI-83/84 calculator that it gives you instructions for. Right? So the first thing I want you to do is I want you to enter this data into a list in the calculator. So first thing it says to do is press stat. Right? So a lot of the things in this class, you're going to start by pushing the stat button. So if you're on a test and you can't remember, oh, I don't remember how to do this, try pressing stat. See if something looks familiar. Right? Then when you press stat, you get, it's not shown here, but you get 3 menus across the top. The first one says editor, the next one says calc, and then the one after that says test. So we want an editor right now. So in that column, which is the one that's highlighted by default, the first, there's what, 5 things there? The first one also says editor, right? So that's one we want. So just press enter while it's highlighted. Or you can hit the number 1. And up will pop this set of lists. Right? So do you see those? You should have L1, L2, L3, and then if you scroll over, you get all the way to 6. There's 6 of them in there for you. Okay? And then you get blank lines if you've never used it. If you have used it, there might be numbers in there. Right? Does anybody already have numbers in their list? Okay? So the first thing you want to do, if you have numbers in there already, is delete them out. And you're going to clear the list. So if you arrow up until this is highlighted, press enter, and it'll give you a blinking cursor down here that says L1 and it's blinking. Then you can push the clear button and enter, and it'll clear that list out. Okay? Now, some of you at some point, well, I should say most of you at some point are going to accidentally hit the delete button when you're supposed to hit the clear button, and that list is just going to go away. Ah, I lost L2. And you'll come up with your, how do I get it back? So to get it back, you just, that menu, editor menu, the bottom one says set up editor. Just run that. Just hit that 5th one and it'll be back. Right? So do not despair. Now, just do this. Enter all those numbers into the list. You're just going to type a number in, hit enter. Type a number in, hit enter, and so on. You got to get your cursor back into here, though. Okay? So everybody got the list entered? All right? Then the next thing it says is to press the stat button again. So press stat, go over to calc, and then choose the top option, which is 1var stats. Now, in this class, the way I teach this calculator is that calc menu, top choice is 1var stats, and that's the only choice in that menu we're ever going to use. There's a 2var stats right below it, and then a whole bunch of other stuff. And the calculator, when we get to linear regression, or I'm sorry, the textbook, when we get to linear regression, is going to have you use some of those things down there. And there's a different way to do it that I like better. So, I mean, that'll work if if you're stuck at home and you have the book, you can follow it. It'll work, but it has more potential for error. So anyway, choose 1var stats. It says press enter twice. And I'm not real fond of that, but on another page it gives more detail. But that's using the default, and the default is L1. So if you just press enter once, it'll pop. It depends on how new your calculator is. You're either going to get 1var stats and a blinking cursor on your screen, or you're going to get 1var stats across the top, and then it'll say list, colon, freak list, and then calculate. Right? This is the newer style. Either way, if you just hit calculate, it will default and it'll use L1 for the list. But get in the habit of telling it which list so that you don't get trapped into analyzing the wrong list on a test or something. To get L1 or L2 or any of the lists, a common mistake is to use the green button, which is alpha, and then type an L, and then type the letter 1. You can't do that. Look on your 1 button on your calculator. In either yellow or blue above it, you'll see a little L1. Everybody see that? To get to those yellow or blue characters, what do you got to hit first? Second function. So you hit second function, then L1. To put an L1 in this blank, or to put an L1 there. We're going to use this freq list in a minute, but for now we don't need it. We don't have a list of frequencies, and so leave it blank and go down and hit calculate. Now, hopefully you match this. The top thing, when you do calculate, you get a whole page of output. The top one is X bar. Does it have 5.6666 repeating? Okay, good. Below that is sigma X. What's sigma X? That's all of them added together. It's the top of that formula over there. Right? Then below that is sigma X squared. That's the sum of the squares of the x's. We won't need that. Below that, I forgot what's below that. SX, right? SX is Friday's lesson. That's standard deviation. I should say that's sample standard deviation. The one below that is that lowercase Greek sigma. And that's the population standard deviation. And then below that is N. Right? It says N equal, and it should be 6. N equals 6. So always look at the N just to make sure you got the right number of things entered. If it tells you there's N equals 7, ooh, I got something in this list I didn't mean to get. Right? All right, and then there's an arrow by that N equals 6. And that tells you, hey, there's more to look at if you arrow down. So if you arrow down, you get what's known as the 5-number summary. And that 5-number summary is shown in the book right here. Everybody see this? Your numbers won't match because it's different data. But you should see min X, Q1, med, Q3, and max X. The min and the max, that's pretty self-explanatory. What's med? That's median. Right? Any guesses as to what Q1 and Q3 are? Those are called quartiles. That's in a couple of sections down the road. We'll get to that, right? But just know that they're percentiles. That's 25th percentile. The median is the 50th percentile, and then Q3 is the 75th percentile. But we'll get to that. But your med, your median, you should have got 5. Everybody get 5? Woohoo! All right. Now you know everything you need to know. Well, not really. Let's do something now to this data. See this value of 12? Go back into your list editor, arrow down to highlight the 12, and change it to 120. Right? Everybody there? Now redo the 1var stats. So run 1var stats again and get your output. So this is with a 12. What do we get when we do a 120? What's the median? 5. Still 5. It didn't change. What's X bar? 23.6 repeating. Up here, the two were pretty close to the same. But when I change this to a 120, now they're vastly different. What does that show you? If you got an outlier in your data, the mean is heavily affected by that. the mean is not a good measure of central tendency or measure of center for data sets with outliers or skewed data. If data is pretty symmetric, mean and median should be close together, and in that case we would prefer the mean because it uses all the data points. But if some of those data points are outliers and they're going to skew our idea of what the typical or the center is, then we wouldn't want to use those outliers. We would go with the median, which uses the middle number. Okay? So you'll have some homework questions where they ask you, for this data set, which is the better measure of central tendency, the mean or the median? So what are you looking for? How do you make that decision? If there's any outliers. If there's outliers, you say, oh, I better be using the median. Right? Here's an example, and this is a true story. Now, when I say it's a true story, you have to give me a little bit of license. What I really mean is it's a semi-true story. It's mostly true, but I might have forgot some of the details. But I know most of the details. But a lot of departments at colleges, including our math department, they'll publish little pamphlets for recruiting students. Right? So the Department of Communications at, I think it was Virginia Commonwealth University, in 1984, published a pamphlet to recruit students, and they said the average starting salary for our graduates last year was $55,000 a year. Right? That's a pretty good starting salary with a bachelor's degree today. And not dissing anybody in communications, but communications usually doesn't pay as well as like mathematics and statistics. That's a little plug for mathematics and statistics. So $55,000 in 1984 was a heck of a good starting salary. So I don't know about you, but if I read that as a high school student, I'd be thinking, that's what I'm doing. Right? I'm going to go into communications. Well, it's a case of telling the truth, but not the whole truth. In the Department of Communications, graduating the year before, was a guy named Ralph Sampson. Anybody know that name? He was starting forward for the Seattle Supersonics the next year. So his starting salary was like $1.5 million. Of course, he wasn't using his communications degree. Should they have reported the mean or the median? They should have reported the median. But it was better for them to report the mean because it got pulled into that long tail towards the outlier. The mean is not resistant to outliers. So had they reported the median, it would have been down around 28,000, which is more typical of a communications major at that time. Right? But it almost doubled when they threw in this one huge outlier. Right? So don't do that. This is not a course in how to lie with statistics. Okay, any questions on how to use your calculator? Okay, then there's one more concept that we need to talk about, and there's a homework set like this. If I have time, we'll do it, but if not, we'll just suffice with the example that I'm going to go through. I want to collect a little bit of data here from you guys. All right? Now, what I'm interested in is the number of siblings that you have. Does everybody know what that word means? Number of siblings, right? So I'm going to make a frequency table, and I'm going to let x be the number of siblings. So what are the possible values of x? 0. You could have 0 siblings. Could you have 1? 2? Okay, whole numbers from 0 up, right? In my last class, they were getting all mathematical on me, and somebody threw out, real numbers. Could be all real. No, real numbers includes things like square root of 2, right? You can't have that. You can't have 1.8 brothers. So it's whole numbers, or also called the counting numbers, right? Whole numbers greater than 0. All right, so everybody understand what we mean? So what I want you to do is I want you to raise your hand if you have 0 siblings. If you're an only child, you have 0 siblings. Nobody? Man, no wonder you guys are so normal. Okay, 1 sibling. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Half siblings count.
What's that?
Half siblings count.
Yeah, count them as a sibling.
What about step siblings?
Count them as a sibling.
Oh, God. Okay.
So do you want to change your answer?
No. I didn't vote on you yet. We're good.
2 siblings. Raise your hand. And I'm going to raise mine because I have 2 siblings. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? 3 siblings. 1, 2, 3. 4 siblings. 1, 2.
7.
Is anybody who hasn't voted yet?
8.
Oh, gosh. Okay. 5, 6, 7, 8. Now, these ones that you guys are getting these huge numbers, are they the step sibling thing? Okay, I'm going to change my answer to your question. Don't count step siblings. All right? So, what about 5? I got 1 with 5. 6. 7. Wait, 6, I didn't write anything. So it was 0, right? There weren't even, so 0, and then 1 with 7, or was it
Yeah.
just 1? Okay. And 8. Got 8 siblings. Anybody with more than 8? Okay. Okay, now, before I go on, when this happens, when you run out of values and you're done, you can just stop. But sometimes people will collapse and go, well, you know what? There's only 3 people that were 5 or more, and they'll make a frequency table, and they'll have the last one will say 5 or more, and then it'll have a 3 over there. Then it gets tough to do summary statistics because, well, what do I do with that? I don't know how many they had. All I know is it was 5 or more. So you make some decision like, well, let's call them all a 6. Or let's call them all 5.5 or something like that. But you have to make a decision. If you don't have to collapse like that, it's best not to. Just get it all. Get the data. Okay? Now, compute for me the average number of siblings. What's the average? Do it real quick. Holly, did you not bring your calculator?
I have it in my car.
I gotta go there.
We still count the 0 ones? I mean, like...
Just give me the average. Don't be asking questions. See, I want you to get it wrong the first time.
5.3.
Okay, I heard one person say 5.3. Okay. 3.3.
3.
I got another one, 3. Anybody got an answer they're pretty confident about? Because you're all giving me that look like... Now, I'm drawing a blank on your name. Stephen. Stephen threw out the 5.3, and then he went, wait, that can't be right. And that's what I want you to do. Not just in this class, but in every class you ever have, and the whole rest of your life. When you're out on the job, when you get an answer to a question, take 5 seconds and go, does that seem reasonable? And he did that, and he said, wait, that doesn't look right. Right? A lot of times you can catch mistakes that way. If you say, well, that number doesn't make any sense. I purposely didn't give you any direction on how to do this. So when I say give me the average number of siblings, how many people averaged these frequencies? Okay, about a third of you, raise your hand. Are these number of siblings? No. This 10 means there were 10 people that had one sibling. So if I want to enter this data, how many people answered the question? Add the frequencies, 10, 19, 22, 24, 25, 26, 27. So there were 27 of us, and I was one of them, that answered the question. So that's my sample size. That's n. The sum of the frequencies is my n, right? Well, if I average those numbers, the sum is 27 divided by, sum divided by however many numbers those were. That doesn't have anything to do with siblings at all, right? So that's not the right way to do it. How many people averaged this column? Okay, that's closer. Still wrong, but it's closer. This is number of siblings. But if you just average these, what are you failing to account for? How frequent each of these values is. Now, this is not how to do it the easiest way, but one way you could do this is to go into L1 and start entering the values that were answered. How many zeros were there? 0. So I don't have to enter any zeros. How many ones were there? 10. So you enter 10 ones. All right, so there's 10 ones. And then there's 9 twos. And enter all 27 numbers that way. Right? That'll work. But there's an easier way. Your calculator can take care of this using what's known as a weighted mean. What I want to do is I want to take the average of the x's, but I want to weight them by how often they occurred. It's called a weighted mean. So a weighted mean x bar equal the sum of each value of x times the weight for that x. Divide by the sum of the weights. So the Wi is the weight for ith x. Now in this case, the weights are just frequencies. But they could be probabilities. They could be, like I told you at the beginning of the semester, that your grade in here would be, your tests would have, your test average would be 60% of your grade. The final would be 20% of your grade. And the homework would be 20%. Well, I'm weighting things. So you could get the weighted average. One of the homework problems has, a fictitious student. Here's the weights they're going to use. Here's their grades up to this point. What does she have to make on the final to get a B in the class? That's a question I get every semester about 20 times. What do I have to make on the final in order to get an A in your class? And I say, hey, it's one of the homework problems. Go figure it out. If you can't, you ain't getting an A. So the way we're going to do this in our calculator is put the x values into L1 and put the frequencies into L2. Right? Now, before you do it, get a ballpark estimate of what you think the number should be. If you look at this data and I say, what's the average number of siblings? What does it look like the answer should be? Around 2? What are the two most common numbers? 1 and 2. Most likely, the mean will be between those two numbers. It's probably going to be 1 point something real close to 2, or maybe 2 point something small. Right? Think of, just mentally do a histogram or a bar chart. Stand over here, turn your head sideways and go, I didn't have any zeros, but I got 10 ones, then I got 9 twos, and then, so I got this really skewed distribution, right? The typical should be weighted up here towards, right? Towards where the tall bars are. Yes?
Can you just like multiply
multiplied the 2 and got that number and then divided by 27.
Yes, and that's exactly what you're going to do. So this thing on top, your calculator will do that for you, but you could have done it that way. You could say x times w and say, well, this is 0, this is 10, this is 18, this is 9, 8, 5, 0, 7, 8. Sum those up, and that's what you're doing here. Sum of x times w. And then divide by the sum of the weights, which is 27. You get the answer. But do this. Go L1 for the x's, L2 for the frequencies. Go back into 1 var stats. Do you remember how to do 1 var stats? So you're going to push the stat button and then calc and then 1 var stats. And if you have the newer type of calculator, you'll have list and then freq list. Now it makes sense what they mean by freq list. The list of frequencies. So this is going to be L2. This is going to be L1. And remember, to get L1 and L2, you push second function, then number 1, second function, number 2. Right? If you have the old style calculator, like the TI-83, you're going to have L1, comma, L2 up there. And then press enter. And there is a comma button above the number 7.
So we want sigma, or which value we looking at? Just x bar is the one?
For the mean, we want x bar, but we're going to get, I want to see them all. But so did everybody get that? What'd you get, Stephen?
It was 2.4.
2.4. Is that all there is, or is there more decimal places?
More decimal places.
Give me one more decimal place.
The 2.41.
2.41. Okay? Is that in the ballpark we said it ought to be? Yeah, we said it ought to be around 2. I was kind of guessing it might be on the other side of 2 because there were more 1s than there were anything else. But we've got these outliers, a long tail, so it's pulling that mean up. Look at the median. What's the median? 2. Because think about it, the median is the middle number in an ordered set. So I erased it now, but if I have 10 1s and then 9 2s, I'm at 19 numbers already. That's over half of the total, so the middle number is going to be a 2. Right? Does that sound reasonable, that the average number of siblings that people have is about 2.4? Remember, the mean does not have to be one of the possible data values. You can't have 2.4 siblings, but the average of a bunch of people can be 2.4. Understand? Okay, there's one more set of, or type of question that they're going to ask you, and this is one example, but they've got it's more like that, and then that. A, B, C. Oh, it just dawned on me. I have not talked about mode. Mode's easy. What's mode? Most common observation. So if you've got a bar chart, it's the one with the tallest bar, right? In here, what's the mode? 1. The most common observation was a 1, right? It is another measure of central tendency. Now, to this. A, B, and C. Which one would be the mean, which would be the median, and which would be the mode? Okay, C is the mode. It's the tallest bar, most common observation. I have to walk over here by the... I don't know where the sensor is. Oh well. Anyway, There. So C is the mode. What about A and B for mean and median? The mean would be A. The median would be B. How do I know? What happens to the mean in a skewed distribution? It gets pulled toward the outliers, towards the long tail. So the mean's going to get pulled, so that'd be A. B will stay closer to the hump. It doesn't necessarily have to be right at the hump, but it will always be real close to the hump. All right, we will see you on Friday. Don't forget, 2 homework sets due tonight.